Today we are solving proportions. So on Tuesday you guys used proportions, like I said, that's the loose version of the word, to convert between units. Today we're actually going to be solving more abstract proportions, so with unknowns and variables in those proportions. So your essential question is, how do you set up and solve a proportion? And a proportion are basically two fractions with an equal sign in between them. So a fraction is the same as division, correct? Basically. So just like when we're solving equations, we have to use inverse operations. So if a proportion is a fraction and a fraction is division, what would be the inverse of division? Multiplication. So in order to solve a proportion, we multiply. And specifically, we multiply by the denominator. So example 1, I have 7 over 8 equals m over 12. Both of these are division. So I need to get rid of the division by multiplying by the denominator. So the first denominator I'm going to get rid of is 8. So how do I get rid of an 8? Multiply by 8. And whatever I do to one side, I have to do to the other. So we multiply both sides by 8. Watch what happens. On the left side, because technically this is 8 over 1, it reduces. So what are we left with on the left? 7 equals m times 8 gives me 8m divided by 12. Is everybody with me so far? Okay. And then on the right side, I'm dividing by 12. So how do I get rid of that? Multiply both sides by 12. And those 12s reduce. So I am left with 84 equals 8m. And ladies and gentlemen, I'm going to move my work over. How do I get rid of the 8m? Divide by 8. I ran out of room. So this is 84 divided by 8 equals m. And let's actually do that. So if I divide 84 by 8, 10.5, how does that reduce as a fraction? 84 and 8 both reduce by what?
4.
By 4, so that gives me 21 over 2 equals m, which is also 10.5. I would accept either answer. So this is the long way. We don't have to do this every single time. If I had multiplied, couldn't I have multiplied by 8 on both sides at the same time that I multiplied by 12 on both sides? And that would have made things go a little bit faster? That is called the cross products property. Okay, so I'm going to erase this. So the cross products property tells us that cross products are equal. Okay, and that's essentially what we just proved using an example problem. But now we're going to apply that so that we can get just a little bit quicker with all of this. So you don't have to multiply by each individual denominator every single time. But I'm also going to up the difficulty a little bit. So example 2 says 4 over 3 equals negative 8 over x. So as a student, I am thinking, oh shoot, the negative is throwing me off. I don't know if it is attached to the 8 or to the x. Any ideas?
The negative always floats up.
Yeah, so let's think about it, guys. If I attached the negative to the 8, that would be a negative divided by a positive, and which would give me a what? What's a negative divided by a positive? A negative. If I attached the negative to the x, it would be a positive 8 divided by a negative, which would also be a negative. So does it matter? No, but you do have to attach it to something. What Jonah said is it always floats up. I always attach the negative to the numerator, just so that I'm consistent. Okay? So I always go ahead and assign the negative to the numerator, just so that it's consistent with always the same. The one thing you do not want to do is assign the negative to both, because that makes it a negative and a negative, which is technically a positive. Does that make sense? So you can only use it once. I always attach it to the numerator. Okay? So let's use the cross products property. Cross products means that I multiply diagonal, and that only happens when you have a proportion, which means there's an equal sign in between. Okay? So it's just like clearing the denominators of the fraction. So if I were to multiply by both sides by 3, I end up multiplying negative 8 times 3. Correct? Equals, if I'm multiplying both sides by x, that's going to be 4 times x. So 4x. So essentially what I did here is I multiplied both sides by 3 to reduce the 3 on the left, right? And I multiplied both sides by x to reduce the x on the right. We just didn't write all those steps. Okay? What's negative 8 times 3? 24. Negative 24. So we have negative 24 equals 4x. And then my last step would be to divide both sides by 4. And I get x equals negative 6. A lot faster, right? But I wanted you to do at least one the long way so that you know why the cross products property actually works. So it works because essentially what you're doing is clearing the fractions. She said, on our test, do you want us to write it as an equation? Yes. So on your test, you must write that step. Actually, every single time you have to write that step because that's showing your work. It's showing that you are using the cross products property. If you go straight from the problem to the second step, technically you're not showing me what you did. Does that make sense? So you must show me what you actually multiplied. Example 3. B minus 8 over 5 equals B plus 3 over 4. Can we use the cross products property here? You can, actually. The thing that I want you to do, though, whenever you see a problem like this, put parentheses around the B minus 8 and the B plus 3. Technically, that is one number. We just don't know what it is yet, right? Because we haven't plugged B in. So, I need to clear the fraction on the left, which means I would multiply by what? 5. So we would have 5 times B plus 3 equals. And then I need to clear the fraction on the right, which is 4. So I would multiply the left side by 4. 4 times B minus 8. What other property? So if you were to tell your steps, the first step would be what? Cross products property. You don't have to write this. Product property. Kiki, question.
Oh, no,
Oh, the next step. Okay, what's my next step? distribute. So we would use the distributive property. So that would be 5b plus what, ladies and gentlemen? 15. On your first quiz, which I will hand back to you tomorrow, probably the most common error was the distributive property not being done correctly. You are forgetting to multiply by that second term. Equals 4b minus what? 32, and that is distributive property. So just practicing or writing our steps, justifying our answer. What step would you do next, Christian?
I would isolate the variables, so I'd subtract by 15 on both sides.
Okay, so Christian said the first thing he would do is to subtract 15 from both sides. So we're going to do what he says, minus 15. Because 15 minus 15 gives me 0. So I have 5b equals 4b minus 47. And who can tell me what property was that? Who remembers the name? Sienna, do you remember? No. Christian? It is an inverse operation, but what did we actually do, Malika? Oh my gosh, you are so smart. Subtraction, property of equality. Okay, because we subtracted, and there's an equal, and we subtracted from both sides, which is what makes it the equality part. Okay, so going off of Christian's work, the next step would be what? Elisa, what would be my next step? Excellent. Subtract 4b. So everybody should know this 5b minus 4b gives me 1b. Or just b, equals negative 47. What property did we use there, Rebecca? Look at, well, we canceled, but the exact name of it would be? Subtraction. We used subtraction, right? Didn't we use subtraction again? So because we subtracted 4b, it is also the subtraction property of equality. Subtraction prop of, I'm going to use equals, but really you should write out equality. And that's it. Okay? How would I check my answer? Kiki, how would I check it? Plug in negative 47 for B. The thing that I want you guys to get comfortable with is like justifying your work, writing out why you can do what you did. Is it okay that we use the same property twice in a row? Totally okay. Okay. What if I had added 4b instead? That wouldn't be the subtraction property. It would be the addition property of equality. Okay. So it's okay that we use the same step. It's different numbers. Okay. So I'm just trying to get you used to the academic language. Example 4. An MP3 player has 2 gigabytes of storage and can hold about 500 songs. Does that information sound important? Probably. So I'm going to underline 2 gigabytes of storage and 500 songs, or double underline, right? A similar player has 80 gigabytes of storage. Oh, 80 gigabytes of storage. That's it. About how many songs can the larger player hold? So that's my question. Is this type of annotating helpful to you guys with the word problems? It will be when we get to longer problems. Okay? So we're actually going to set up a proportion for this type of problem. My first proportion says 2 gigabytes of storage holds about 500 songs. So I'm going to put 2 gigabytes over 500 songs. And the reason why I know it's going to be a proportion is that word's similar. So pretty much it's like a comparable player. It just has a different amount of storage on it. So, and this is where these problems are different than conversions, because we're not trying to cancel out the units. We're trying to set up something that is similar. So where is that 80 gigabytes going to go? In the numerator or in the denominator? In the numerator. Because I'm not converting units here. I'm trying to figure out how many songs that similar player holds. So because I put gigabytes over songs, the equal sign means that they have to be equal, right? So I have to put gigabytes over songs. Could I have flipped it and done songs over gigabytes? Yes, you would have gotten the exact same answer. Was that your question? Yeah. It really doesn't matter as long as your units match up because of that equal sign. Does that make sense? So when we are converting, we want those units to reduce because they're not equal. But here I'm saying that they are equal. Brianna, what did you do first?
We cross-multiplied the 2 and the x and wrote 2x, and then 80 times 500 was 40,000.
Okay, so then you did 2x equals 40,000. Okay, and then what?
And then divide by the 2 on both sides.
Okay, and you got x equals?
20,000 songs.
Oh my gosh, I was just going to say 20,000 what? 20,000 songs. Okay, how many of you agree? Thumbs up, you agree. Everybody, good. How many of you, now put your hands down, how many of you wrote songs after the 20,000? If you did that, put a big fat star next to it, because you did exactly what you should. If you did not write songs, write it in now. So remember, with word problems, you always want to indicate what exactly 20,000 what, right? You have to tell me 20,000 what. Excellent. If you got 20,000 songs, turn to your neighbor and give them a high five. So guys, here's what I'm going to do. This is the first time we are ever doing this. Part of your homework tonight is going to be your questions and summary. I know, okay? So part of your homework tonight is going to be your questions and your summary. Got it? All right. You can put these away.